We are happy to have you online with us this Saturday morning. With a mission to guide students transitioning from campus to career, Edugraph, the education vertical of the Telegraph Online, brings you this webinar on engineering education in India, future trends, presented by Amrita Vishwa Vidyapeetham. We are honored to introduce our esteemed speaker for today, Dr. Sasangan Ramanathan. Dr. Sasangan Ramanathan, Dean, Faculty of Engineering, and Professor, Department of Chemical Engineering and Material Science, brings with him over 25 years of international research, management, and leadership experience. Dr. Ramanathan joined Amrita University in 2014 and is committed to excellence in research-led education that culminates in positive contributions to society. He is a strong believer in an educational process that promotes creativity and innovation through sound fundamental knowledge. Dr. Sasangan Ramanathan holds a BTech in Chemical Engineering from NIT, Trichy, as well as a Master's and PhD in Chemical Engineering from Clarkson University, USA. He has authored and co-authored 50 plus publications and holds 12 US patents. Now I hand over the session to Dr. Ramanathan.
Thank you. Thank you very much, Anuradha.
Thank you.
A very good morning to everyone. I'm very happy to be here on this Saturday morning, share some of my thoughts about engineering education in India. What can we expect in the future? I don't know the mix of the audience here, but if there are students who are pursuing their 11th or 12th and you're attending this webinar, it might be useful because right now you're probably looking at, where do I join? What do I do? Which is the most lucrative branch? Where can I get jobs? A lot of questions out there. And for people who have already enrolled in engineering and you're looking at where you should, sort of move your career, this might be a good place to at least listen to things that we think might happen. Now, what I would do is share a PowerPoint slide with you, maybe about 10, 12 slides that I will walk you through and open up for questions. Now, there is a lot of demand for engineers globally. And specifically, if I look at it for skilled workers, skilled work, we not only require engineers in the software companies. I don't belong in the software company. I've done my PhD, my undergraduate in chemical engineering, worked in semiconductor industry. But there are sectors like education, banks, healthcare, defense, railways, manufacturing, agriculture. All of them require engineers and smart engineers. Now, with that sort of an introduction, let me just share the slides that I have prepared for this webinar, and hopefully I can walk you through that and later on address questions. What I thought of sharing today was, why engineering? A lot of you might be just looking at engineering as something that, people thought, okay, my son or daughter needs to be a doctor or an engineer. That's a parental pressure. Of course, there is peer pressure. Your friends and schoolmates and even college mates are doing something. So you wanted to pursue. But let me tell you what is engineering and who should pursue that. If you're a person who likes to question, explore, invent, discover, or create, then engineering would be an ideal profession for you. You should be able to apply science and mathematics to solve complex and challenging problems. Now you look around, engineering is everywhere, right? Everything that you see around you has got engineering built into it. If you just look at a hospital, a lot of us, when we think hospital, we look at doctors, nurses. But if you actually look deeply, it's 80% engineering inside a hospital. All of the diagnostics that goes on inside a hospital is built by engineers. The equipments and everything that is used is coming out of science and engineering. And if you look at automation, which I have a video again, people say that automation is taking up the jobs of human beings. We are losing jobs. That's a general trend. Absolutely not. Automation doesn't take away jobs. Automation is precisely for repetitive jobs or jobs that require precision, where human error is always there. And if you want to eliminate human error, you try and use some automation that makes it more precise and less prone to errors. And that's what automation is all about. Now, when you talk about automation and you pull back, what happens to the people where do you get this automation? All of these machines and things that do run these things automatically are designed, built by a whole bunch of engineers. And these are not a specific discipline engineers, they're interdisciplinary. You need something to move, you need something to control that movement, and you need to have that movement repeat at a certain interval. These are simple things that I'm telling you, but these are designed, thought through by engineers, and then a cross-functional team, electrical engineer, a mechanical engineer, communications engineer, computer science person. They all sit around, understand what is it that we are trying to solve. And it's an interdisciplinary kind of domain. Now, when they sit down and write and get this thing executed, what you see is an automated machine. Now, what sort of branches, departments are out there for engineering? I mean, the basic fundamental core engineering subjects like mechanical engineering, civil engineering, electrical engineering, chemical engineering, aerospace engineering, and then you have computer science. Now, what we have seen recently in the last maybe 10 years or so, and it's going to get even more complex. We have electrical, electronics, communication, and computer all being muddled up, and it's one sort of a very highly interdisciplinary domain. Where we had electronics and communication, electrical and electronics, now you have to mix the electronics, communication, computer, and electrical together. And that's when you become a sort of a person with a wider expertise. And if you look at Amrita, we also offer students to go dig deeper. We offer specializations and minor programs. And why do we do that? A mechanical engineer should be able to understand, a lot of you may not know the Internet of Things. They should understand sensors. They should understand how to control things. So we offer minor programs for engineers of different domain to be able to get a feel and a knowledge about other domains, like in electrical, in electronics, in computer. A lot of us talk about artificial intelligence and cyber security. That's another big terminology that's come up in the recent days. This is an emergency room in a hospital. It's an ICU, intensive care unit in the US. You don't see any doctors, no nurses, but a whole bunch of gadgets. Now you see a lot of tubes, monitors, and gadgets. Now, what are these in the intensive care unit? 85% or more. It's about equipment designed by engineers, and it's mechanical, electrical, electronics, computer science, sciences. There is physics involved, chemistry involved in all of these designs. Now, how does a doctor diagnose these days? Anybody who's gone to a hospital understands that we walk in and we go through a whole bunch of tests. And those tests are done by equipments designed by engineers. The test results are interpreted by the doctors. Now, we didn't have all of these sophisticated equipments in the past. Every time we turn around 10 years later, you'll find a lot more sophisticated equipments. Again, medical diagnostic, early prediction is what everybody wants, so we can prevent the disease from spreading or causing extensive damage to anybody. So this evolution of coming up with newer and newer gadgets to diagnose diseases comes from engineers. So hospitals are 80% engineering, and that's what I meant when I tried to explain this verbally. Now, this is a automated bottling plant, 7,200 bottles per hour, an unbelievable number of bottles that get packaged every hour. Now, if you look at this factory, yes, there are about 3 4 people maximum for a plant that's producing 7,200 bottles per hour. Now, you wouldn't be able to manufacture at this rate using human power. And you're also prone to errors. I mean, these bottles have to have some precision cleaning, precision filling, labeling, packaging. And that is what, and you look at the amount of equipments that are there, the sensors, the automated movement of all of these little things. Look at the number of wires. Look at the movement of every one of these gadgets. So automation, the engineer's responsibility is not to sit and fill these bottles with water. It's more of designing these equipments that can automate. So you're never going to lose a job, or manpower is never lost, but manpower is used for a different purpose that makes production more efficient
Right.
and productivity goes up. So this is exactly what is happening in the automation arena. Now, this is again interdisciplinary. You've got mechanical, electrical, electronics, computer science, a whole bunch of engineers. Now, this is a slide I was talking about where you have conventional engineering disciplines on the top and then the emerging ones on the bottom. Now, here you see a lot of different combinations of, clubbing electrical, electronics, communications with computer science. And within computer science, we have what's called artificial intelligence, and all of you here today know that AI, ML, data science, all these are buzzwords. And if you look at where we are today, we are all moving into a digital economy, digital, digital, digital. Pretty soon, our moms would be able to cook their dishes by the touch of a phone. And that's where we are heading. Now, when you migrate to digital, everything is data driven. Now, security becomes extremely important. And I'll tell you, even today, I don't do online banking because I'm still scared of security and information theft. But a lot of us have the courage and we have gone, and it's just my personal opinion. But cybersecurity is an extremely important area that will come and it will be there forever because we are migrating more and more into digital. Now, I'll just quickly walk you through how we learned. We, in the sense, about 25, 30 years ago. Education in the past was mostly running around looking for information. Nothing was in our palm. We didn't have information handy with us. We had to go to the library, talk to teachers and experts to get the required information. Everything was hard copy. We had to go flip through pages and pages of things and photocopy them to bring them back home or to the hostel and read them. I've seen typewriters, but I don't think any of you in this age and day understand what's a typewriter. A lot of the communication happened orally. We had to take notes in the class because once it's erased, it's gone. I don't know how many of you are familiar with the kind of phone you see on the bottom left. I have seen that. Maybe you have not. That's a rotary dial, which is obsolete now. And even the one that you see in the middle is obsolete because those PCOs, the public call centers, are all gone. Mailbox, you might still find few here and there, but mostly these days we use every social media platform, WhatsApp and emails possible to communicate. So that is in the past, and what are we going to do now? The education and as we look forward. Everything is in your palm. Information is available with you. You might think, why am I saying this? The next slide will take you through why am I saying this. E-library, e-books, everything is E, and you got computers, printers, smartphones, smart tabs, everything, and information and the lectures are all available to you, available in your palm because you can download it at any time. You have access to the lectures that were held 20 days ago. So I don't need to sit and remember too many things. So what do we expect from engineers in the future? Now we need to migrate. You see a little box that says understand, analyze, evaluate, and create. We have to migrate more towards the right. Remembering is not the most important thing now at this day and age because information is available. You can click and get the information. So you don't have to remember. So what do we do? High schools are also changing. I think high schools are also migrating from remember more into understand and analyze. So if I came to India from the US in 2014. Now what happened? That whole the digital revolution was going on, but the adoption was still a bit tough. People were still stuck in the old mindset of I have to write on a piece of board, use a chalk, people have to take notes. But thanks to COVID, we all quickly migrated from this old style, old fashioned to truly digital. And at Amrita, our digitalization had started way back in, I think, 2009. I joined in 2014, and I could see that there was so much infrastructure already there for us to migrate. Now, in high schools, you've probably been more into the remember and understand. I understand you all have to get good CGPAs, good grades in order to be able to secure a good college seat in a college and pursue your dreams. And this will also shift. In the high school, we will see more of apply, analyze coming in. So the transition from high school to college will be a lot easier as we look forward 10 years from now. But today, as you switch from high school to engineering colleges, the first 2 years, you're mostly trained into this understand, analyze part of it. You're trying to apply things that you've learned and not try to remember. So you're more of application oriented. In years 3 and 4, you will be trained to migrate towards the right. Start looking at evaluating and creating. At the end of the day, an engineer is supposed to create something that solves a problem. Now, I have told you how many different branches are there. There could be many more, but I just listed some of the core things. This sort of philosophy is applicable to all the branches, regardless of which program you get in. This is what we expect out of future engineers. So then how do you become an excellent engineer? Now, I don't know how many schools allow students to question, but they should. If you're already trained, you know what to ask, when to ask, and you're constantly questioning something, why is this happening? What if I do this way? How do I do this? These are more learner centric. This curiosity of asking questions triggers more and more answers, and you start digging deep and you truly understand. And that leads to what I call understanding the concept. That's the most important thing. Once you get that skill, then solving a problem becomes easier because now you are able to define a problem. When I was in school, it was always about answering a question. I was never asked to set a question. Now, here, we're saying you all should be setting the question, which is actually defining the problem. Now, if you look at a pyramid as an engineer, where I had shown from left to right, remember, understand, apply, evaluate. I'm showing that in a pyramid form. Now, I graduated out of high school and I never went up the pyramid. Now I'm stuck at that remember, understand. I will be an individual with an engineering degree. I have a degree, but am I a true engineer? Is questionable. Now, if you move and migrate up in that pyramid, yes, you will be a true engineer because you have the ability to create. You have the ability to analyze, evaluate. That is what is a true engineer's characteristic. So what do you have to do? Choose an institute that encourages learning through questioning. That's important. That sort of freedom, that sort of culture has to set in. It is no longer a monologue, it is more participatory. A student and a teacher or a mentor. I don't call them teachers anymore. Here we call them mentors at Amrita because they're mentoring. You do all the learning, they're mentoring you. And that happens through questioning and discussion and participation. And so getting into the right institute that has this sort of a culture is important. When I did my undergraduate, or maybe 20 years down the road, or even last 10 years ago, how do we assess somebody's knowledge? We have a big exam, 100 marks, 3 hours, sit there and answer all the questions, and then you get your grade. Beautiful. So there are people who are very knowledgeable, good students, great students, but they get jittery when they go for an examination. They just go blank. And that's not a fault of an engineer. If you want to showcase your skill set as an engineer, the pedagogy should change. It is no longer only oriented towards examination. The learning outcome and assessment of your learning should be more hands-on. You must go through problem-based learning. You define the problem, you go find the answer. When you go find the answer, you go dig deeper and deeper, and you have to go to many different locations, places, or even in your Google, iPhone, or smartphone. You have to dig deep because you have defined an open-ended problem. So that's more of a project-based learning. You will work as an individual, or you can work as a team, depending on where you join and who's the mentor. But it is all about project-based. It's all about participative. It is no longer fixated on examination. Now, if you want to define a problem, in fact, you should see and feel the problem. And that's where the experiential learning comes from. I don't know how many of you have spent 2-3 weeks in a village, let's say where there was no power, no toilet. When you go spend 2-3 weeks, you truly understand the issues that the villagers face. That triggers your brain to say, okay, you know what? I need to solve this, and how do I solve it? So that gives you that motivation. That's experiential learning. You have to go experience. You come back, use your knowledge, take a solution back to that place. And that's what we encourage. And this is what will happen in the future, no matter where we go. Eventually, in about 5 years out, most of us will lose this examination part. It will be more project-based learning. How do we prepare you? Now, all of you might say, okay, I'm doing my BTech degree or master's degree. All of us want a job or find some great career, go abroad. We all have our dreams. But there are certain fundamental attributes, regardless of which discipline you're in, which college you're in. These 12 attributes are important, and it's not because I wanted to list them. This is what a HR person in a company would look for, a foreign university would look for, if you want to go for higher education. The first one is, of course, sound technical knowledge. You must know who you are and what you wanted to learn, and have you learned it? And that requires your dedication. I might be good technically, very knowledgeable. If I'm not able to communicate, I will never be able to get my ideas across to a team. Ability to understand, analyze, solve problems. I already told you about it. Innovative thinking. Don't put yourself inside a box and keep saying that I will find a solution. No, the box should be open. Ability to learn new things. These are very critical, and I don't know what sort of audience I have, but unless somebody has at least 80% of these skills, it will be difficult. The last one, which is time management. I mean, it's at the bottom, because even today, I find it difficult to manage my time, honestly. That's a whole new art. But I'll give you an example. When students tell me that they don't have time for many, many things, I just tell them, you leave your smartphone in my office for a couple of days. I bet you'll find a lot of time. Many of you might be thinking, yeah, it is true. That includes me. If I keep the smartphone on, or if it's dead, I find plenty of time. But managing our time is extremely important, because everything is a clockwork. Integrity, discipline, that comes along with the time management. Now, how do you get all of these skills? I talked about you go learn project-based this and no examination. You have to be a master of your domain. Yes, you've done all that. How are you going to learn how to be a team player? How to have great interpersonal skills? You must be a team player if you want to be successful in any organization. You must have the passion to perform. And that's why most of the places, educational institutions, they have other things besides academics. You've got life skills that teach you communication, aptitude, thinking out of the box, interpersonal skills, activity-based learning, extracurricular activities. This is a very, very important thing. Unless you get involved in extracurricular activities, you will not understand what is interpersonal skills, what is team player, the attitude of an individual. We all have our personalities, and none of us are perfect. But we have to learn how to live, coexist with a bunch of people. And when you get into extracurricular activities, your academics should not suffer. That comes from time management. So it is this holistic approach that makes you an extraordinary individual. So you can be an ordinary person today because we have gone through the protection, the safety at home. We've gone to school, come back, secured our grades. But if you truly want to be extraordinary, get involved in many more things, and eventually you get all of these attributes. So you go through the 4 years. Let's say you enrolled for engineering. The first year, I say it's a new way of learning because we've gone from just trying to remember things or remember and understand to now going beyond our comfort zone to be able to analyze, evaluate. We're trying to acquire those skills. Change is always difficult. So you have to get yourself accustomed to this new way of learning. Years 2 and 3, so you get your fundamentals in year 1 on sciences, math, and all that. You're more into your domain specific subjects in the next 2 years, along with the life skills, which is aptitude, problem solving, and all that. So in the 2 years, you have to assimilate, understand, and gain the knowledge that is required for you to be successful. Because the last year, you're going to be more an outward looking individual. You'll be into the internships, opting for higher education. Your focus will be more on career opportunities. So the first 3 years are extremely critical, and the second and third year are the most crucial if you're joining engineering on a 4-year program. What do we expect moving forward? Now we see the way I look at it, there must be a very strong industry academia partnership. Now, that's absolutely essential because we keep hearing that we have a big gap between what the industry wants and the skill set of the engineers graduating from colleges. I think that myth needs to be broken. And if you look at these little hexagons, the middle of all of that is AI, ML, data science. Now that's going to be core in the next 10, 15, 20 years. Absolutely. This is going to get bigger and bigger. That little yellow box will start growing and it'll get into all of the boxes. It's already there. A mechanical engineer will have to learn data science, data analytics, AI, ML. A civil engineer has to do that. Electrical engineer has to do that. So what Amrita has done is we have actually built the AI, ML, all part of the curriculum itself, the core engineering curriculum, because it is a must that every one of you understands AI, ML, data science. Now for artificial intelligence to work, by the way, sorry, AI means artificial intelligence, ML is machine learning. For AI to work, you need lots of data. And where does this data come from? It's actually coming from the core engineering technology. Everything that is built with sensors and that can communicate to a computer, and the computer gets all of that data stored, and somebody's going to sit there, come up with an algorithm to do the artificial intelligence and predictive closing the loop. So engineering core is indispensable. Experiential learning, which I talked about, will become an integral part of all of the curricula. We have already enforced that at Amrita. We've been using that for the last 6, 7 years. There will be more hands-on work, lots of capstone projects rather than examination. This is what I see, and that's what the industry wants. Engineers should be proficient with the use of advanced tools. Now, if I asked somebody in the audience, and I've asked this to my students also, if I were to multiply 2135 times 5143, the first thing our students do is take the smartphone and go to the calculator and ping, ping, ping. They come up with a number. In fact, the way I was taught mathematics is we'll write that on the board and we go through, real numbers and crunching and four rows of addition. That's not done now. And the same way, We have tools, we have computers to help make things efficient and more productive. And most of the students who are into the engineering program should know how to use the latest and advanced tools and gadgets and techniques, because that's what you would be expected to know when you join a company or even go abroad. The most important thing is to learn to identify and define a problem. You will not answer questions, but you will define the problem. The problem statement is yours. That's a key shift, paradigm shift, and flexibility to learn subjects outside of your domain. And that sort of flexibility is given and should be part of everybody's curriculum. Of course, I didn't answer the question. This is one of the questions that most of you might be thinking, which is the best engineering branch. And my answer is quite simple. It's up to the student. Now, a lot of people say that computer science and AI is the key. I'll tell you that comes with a lot of mathematics. You must be good with mathematics. If I'm a student, I'm a kid, and I don't necessarily enjoy mathematics as much, just joining CSE or CSE AI for the sake of joining will not help you, because you will find it difficult to climb that pyramid. You will be stuck in that remember and understand, which means you end up with a degree hanging on the wall, but are you a true engineer? So first thing, my advice is, please follow your passion. Look what you're interested in. My dad wanted me to be a doctor, let's say. Luckily, he didn't do that. I'm scared of blood. If I see blood splash anywhere, I get little goosebumps and I just cannot think properly. Now, how would I ever be a good doctor? That's the kind of question we need to ask. I'm more into mechanical. I'm not into computer science. So I chose something that I thought I would excel in, which luckily I did. And that should be the bottom line for your choice. Not because somebody told you, okay, you do this, everything else is good. No, it may not be. And what are you looking at? You're sitting here in 2023. What is today and what's going to be 5 years from now? You should look at that, because you're going to graduate in 2026, 27 maybe, and beyond. So don't listen to things that happen today to make your decision. Go with your heart, go with your passion. Now, if you look at the job prospects and career in India, significant job opportunities for all smart engineers. I specifically said smart engineers. Make in India, Digital India, Clean India, we're the G20 presidency. There are many growth drivers, and India being the fastest growing economy, which is absolutely fantastic news. Plenty of opportunities for all of the engineers, true engineers. Smart engineers are always on demand, and they will always be an asset to any organization. So great career prospect, regardless of which branch they choose. But choose a branch where you know you can excel. That's the key. What is a package? And there's always this question. I kind of know this because a lot of our students and parents ask this during counseling. Which department, which branch will give the best maximum money? And money doesn't come based on the department. Money comes based on the skill set of the individual. It can be anywhere from 12 to 60 lakhs per annum. And I've seen close to 82 lakhs being offered to some of the students. That pay package that you hear is not because of the department. It is not because of anybody. It is because of that individual who excelled, who became an extraordinary engineer. And that's why they get that high packages. So how do you then become this extraordinary person, an engineer? You should be passionate about what you're doing. You should be committed to what you enrolled in. Always have this can-do attitude. Nobody is less smart or nobody is more smart. We're all smart. It is all about time management and our commitment and focus that takes us across the finish line, that gives you the dream career that you wanted. All you have to do is you come with the willingness to change your learning habits. If you've been memorizing, remembering, and getting good grades, well, that's not what an engineer is expected to do. So that's something that change has to come from you. You have to have lots of enthusiasm and passion to do what you actually wanted to do, and committed. Stay committed to the program. If you can bring that, a little few things in your bag, if you join the right institute and you get the right kind of support and encouragement, I'm sure you will be very confident and flying high. Never stay in your comfort zone. If you never push yourself outside your comfort zone, you will never improve. So if you settle for something easy, you will face the consequences. If you push yourself, you will also reap the reward. And with that, I thank every one of you here who've been patient enough to sit through this presentation, listening to my lectures.
Thank you very much, Dr. Ramanathan. Um, and with that, I think we're going to move on to the Q&A. We have a few questions that we collected from our participants before at the time of registration. So we've already got our questions and we've kind of shortlisted and put together, them into bunches. So I will just run through a few of the questions, and Dr. Ramanathan will be answering your questions now. You've spoken to us about what it takes to be a smart engineer, as you kept telling us, what students need to aspire towards. But we had a very basic question: what should be the path to engineering right from class 11? In terms of internships, placements, and all. And is it possible to study further after engineering?
Yeah, absolutely. I mean, bachelor's degree is a basic degree. Um, Beyond that, of course, you can go for masters. You can change your direction. A lot of people go for MBA. So options are there available in India and abroad.
So kindly share your valuable feedback for students who are weak in science but whose parents want them to opt for engineering. It's a very honest question we have from somebody.
Yes, it's a good question, and
Yeah.
I think if there are parents listening and they're part of this, I would urge that you please let your kids follow their passion. It's like trying to force fit a square block into a round hole. It's difficult. So the advice to the kid is, or the student, try and convince your parents that there are opportunities. It is not just engineering. If there is opportunity for a whole bunch of other uh, disciplines, and parents should also be cognizant that engineering is not the only other option. They should be a bit more flexible and understand the kid, that they should allow them to run through their passion.
Carrying on from the same question, we have another question. Many candidates with engineering degrees are unable to find jobs and end up doing an MBA for better job opportunities. The real trend in today's world is all about AI and software technology. Is there no scope for other branches of engineering? I think this is something that you've also been talking to us about during the webinar.
Yeah, I mean, I honestly don't think that AI is the only thing. Why do students pursue MBA? I think your question was some people go do MBA.
Many candidates with engineering degrees are unable to find jobs and end up doing MBA for better opportunities.
Okay, unable to find jobs.
Yeah.
I would, if that individual who asked this question is here, like I said, if in that pyramid, if you display the characteristics of what a high school student would do, remember and understand only, and not able to apply, companies aren't going to select that individual and offer a job. So everybody that's being left out, it is not because there's something wrong with that discipline. At Amrita, we have all a 98% placed, whether it's core engineering or AI or CSE. It's about the training and the passion and the individual who's enrolled in that program, whether it's core engineering or not, should drive himself or herself to learn more and more, so they are climbing up the pyramid. And that will allow this, or will make this statement go away. Many candidates are not getting jobs.
Speaking about engineering and pursuing other subjects which you're more passionate about, we have a question from someone: which is better, a BTech in CSE or an MCA? and which field has more opportunities? How should a student decide between the two?
Well, um, in all honesty, if you have a BTech or an engineering degree, you get paid more.
Right.
So that
Okay.
okay.
Um,
And by the way, MCA is a postgraduate program. So
mm,
if the student is just finished 12th or about to finish 12th, he or she would have to go through a
right.
BCA
BC.
before migrating to MCA. So BTech CSE would always stand ahead,
No.
at least on paper, compared to MCA. However, again, a BTech CSE doesn't automatically guarantee a high salary. The
Okay.
individual has to earn it.
What is the scope of engineering in the robotics branch? In the future, this branch is going to be in demand because it is going to replace many man-powered industries and can also be used for security purposes. This is something one of our participants has written to us.
Mhm. No, robotics is going to grow. Automation is going to grow.
Mm.
Um, each one has its own domain where it can truly help human beings. Defense technology, I don't need to lose the life of a soldier. I would rather use a robot. And automation
Right.
is completely different. And these are fast growing fields. And India, with this Atmanirbhar Bharat, the government's new initiatives, it's going to be a huge growth.
Kindly share your valuable advice on how aspiring engineers can study efficiently. Again, very, very specific question.
Efficiently. I think
Yes.
turn off that smartphone, keep it aside for a week, learn how to do get your time management. That's the only way to be more efficient. Honestly, if there are so many people, you ask yourself, you don't need to answer to anybody. You ask yourself, how many hours do you spend in front of that phone? And is that really value added? If honestly your answer is no, I can cut it down by 50%, you will be efficient that much.
What are the prospects for somebody who studied sound engineering, and what would be some of the good colleges to study?
I think there are colleges that I don't know the exact names of colleges that offer sound engineering, but it's embedded as part of the electronics and communication engineering with sound engineering as a big specialization. There are also programs that intertwine between electronics and sound engineering. Um, it's a great field with the growing digital new media. It's a great avenue and pathway for somebody to go get a degree. They would have to do a little bit homework because it's a little off of the conventional. That doesn't mean that you shouldn't pursue again. If you're passionate about that, please pursue that. And it's a great domain. When I look forward like 10, 15 years out, it's a great domain.
Is it necessary to take coaching from private institutions for engineering?
I mean, it's good to get there because I'll tell you for two reasons. It gets this focus, razor sharp focus on how that schedule would work because now you don't have time to breathe. Those that sort of a rigor comes in, sets in, which makes you focus more on what you want to learn. So there is a set schedule for learning, and that gives a maybe for JEEs, yes, they might be helpful. But if I'm an individual who has tried to understand things even in my plus one, plus two, those are not really needed. Um, unless you're very specific about IITs. Yeah, those require getting into IIT requires special training.
I think with that we've come to the last question. Before we close the session, we would just request Dr. Ramanathan to share a few words with our students.
You have to come here anywhere, wherever you join, go there with a passion, stay committed, and never give up. Persistence is important, and never feel shy to ask anybody if you don't know something. Most of the time, we think we're asking stupid questions. That is a fundamental problem for lack of knowledge. If I don't know, I would ask somebody. I have no qualms about it. So get there and have this can do attitude and set your goals high, not so high that it's just a pipe dream, but set it high enough that you actually can pursue and accomplish. Folks, anybody who wants a great job, yes, I understand. But if you go through the process and you take everything seriously, get it done, and learn what you have to, the result of that will be a job with a great offer. So go through the process, and I wish all of them the very best.
Thank you so much, Dr. Sasangan Ramanathan, and thank you so much to all our participants for taking your time out and attending this webinar on a Saturday morning. We look forward to seeing you for many such webinars. And Dr. Ramanathan, thank you once again from the entire team for conducting this webinar for us.
All right. Thank you.
Good.
Thanks.
Thank you.